The purpose of this webinar is to provide for the new user of Maple enough information to make the first interactions with the software comfortable, effective, and efficient. So we need to look at the interface, how to enter mathematics, and how to interact with the entered math. When you launch a copy of Maple, new fresh copy of Maple, this is probably what it's going to look like. This is a short 3-minute video, has some interesting information. You can take a look at that. There is a Maple Fundamentals Guide. It's a longer video, about 37 minutes. It's got some good information in it. It will mention the Maple Portal, which is a place where questions like, how do I do this? How do I do that? Are answered. That's very useful. We'll talk about that shortly. There are 2 ways to use Maple, either in a worksheet or in a document. This how do I choose discussion, the details, basis upon which you might make the choice between the 2. Worksheet is probably for somebody who is using commands, and I don't think the way to start looking at Maple is by trying to learn a whole bunch of commands. So we're going to be using the document, which allows for point and click syntax-free computing, something that a new user might want to jump into and start making use of. You can also see here what's called a context panel. As you enter math and interact with it, these options change to allow you to do things to that particular piece of math. Here you will see a stack of palettes. We'll describe shortly how to arrange these palettes and what you might make your document look like as you explore Maple for the first time. Here I've opened a worksheet just to show you what it looks like. You get these red prompts. Every time you hit the enter key, you're going to get another red prompt. The input choices are textual, so you get typewriter characters, and you have to know syntax. For example, if you wanted to differentiate x squared, you would have to make use of the syntax for the command. And the only thing you can do here right now is to hit the enter key, and you get a centered 2x with a derivative of x squared. But notice now the context panel options have changed. You could, for example, make use of this integrate with respect to x option. You get x squared, and you'll notice that Maple has written in the int command, the integration command, makes use of this equation label 1, which stands for the 2x, and it shows you the syntax for that command. But a first approach to Maple using commands for which you have to know the syntax is probably not the optimal way to go. You could click math mode for entry and type the same command. It will typeset, and the x squared will be typeset, and everything else will be the same. You get 2x and so forth. But I'm not going to stay in this worksheet mode. I am going to point out that you have these 3 choices. In the worksheet, you've got the choice text and math. In the document, you'll have this non-executable math option, and I will show you that next. So here I'm in a document. This is what it looks like. You can get a document or a worksheet by going to File, New. You can pick a worksheet or you can pick a document. I have my Maple set up so that when I do a Control N for a new something, I get a document. But you can fix that to go either way. So this is what it looks like. I call your attention to the following. In View, you have this option markers. I always select markers. I want my markers on. You see this column. You have these rectangles. They are called document blocks. They show you where you can insert things. Every time I hit an enter key, I get another document block. Let's go back up here and look at cursor structure. You'll notice there is a black bar on the left edge. If I hit the right arrow key, that bar moves to the right edge and is now thin. There's a difference in behavior. If I put in some inputs, I'm going to type X, enter, Y, enter, Z, enter, W, enter. I've done that with the little bar thin and to the right edge. If I hit the enter key, I will jump to the next input. But if that bar is on the left edge, heavy black, when I hit the enter key, I insert a document block, but do not single step through the document. So you want to keep your eye on that cursor position. When it's to the right, you will single step through. There's another thing to pay attention to. You can do a text input. So that's text. You hit the enter key, you are still in text mode. It's just text. If in the middle of that sentence you want to put in what's called non-executable math that does not execute. So suppose you wanted to put something like, what can we put in here? Let's put in a diff command as non-executable math. Now notice that the box for entry is gray. That's the non-executable math. Let's put in the diff command. Diff x squared comma x. If I hit the enter key, it does not execute. If I were to hit this triple exclamation for re-execution of the entire worksheet, that would not execute. If you go back and look at the box around these other inputs, X, Y, it's bluish. Those are executable. See, that's executable math. So this non-executable math allows you to write a document that has displayed math that you might not want to execute when you hit the triple exclamation or when you single step through. Down here, now this would be live. I put something in here. If I would hit this triple exclamation, the live ones would execute, the non-executable ones would not. So back in a document, we've taken care of this issue about markers. I want to show you one more thing here in the document. It gets set up, view, palettes. Okay, there's a stack of palettes on the left edge of my screen. You can show individual palettes. You can show all the palettes. You can see I have most of the palettes except for about 4 of them, which I don't use. Make your selections. You can move them around with a drag and drop approach. I pick this order. I like to have this order for my palettes. I will show you momentarily what you can do with it, with the stuff in palettes, but you might want to adjust palettes beyond the default collection of palettes. So here we are back in the document. We're going to do some math now. You saw the command for differentiate. So diff x squared, right arrow key to come down out of the exponent, comma, x. Now, we have some choices here. We can hit the enter key, and we will get the center 2x. I'm going to type that back in again. Diff x squared, comma, x. If you go here to the context panel, you see this evaluate and display in line? We can execute that from the context panel. There's a keyboard equivalent. In fact, there are two keyboard equivalents. The one I always use is Control equal. The other one is Alt Enter. My fingers are trained to do Control equal. You notice in line, the differentiation command is evaluated as an equal sign, and the result is to the right. So now you can make mathematical statements. So that's using the diff command. But this is supposed to be syntax free. So now we're going to look at this calculus palette. These are the palette entries. You see this differentiation operator? You type in x, you use tab to move over. You put an x squared in here. I'm going to do a control equal. Now you have a much more pleasing mathematical statement. D by dx of x squared is 2x. There are other ways to differentiate x squared. Here's x squared. If you go over to the context panel, you'll see differentiate with respect to x. And now you get the 2x. There's an arrow. It says what you did to move from the left side of the arrow to the right side of the arrow. Differentiate with respect to x. And then there's one more way we can differentiate with respect to x. Here I'm going to put an x. You can use an apostrophe. The derivative of x with respect to x, x prime notation. If I do a control equal, you're going to get 1. Let's try that again, and this time I'm going to go to my favorites palette. Now, your favorites palette is probably empty. In my favorites palette, I have a prime, a double prime, triple prime. Where did I get those? Well, if you go down here to punctuation, you'll find that there's a prime, double prime, triple prime, even a quadruple prime. Right-click on one of those items, and you have the option to add to favorites. That's how I populated my favorites palette. So I just like the look of that x prime. It looks much more textbooky, much nicer, and the derivative of x with respect to x is again 1. Well, now that we know how to put in some math and begin to learn how to interact with it, let's try graphing. That might be something you want to check out. So let's enter sine of x. This is the syntax for sine of x. If you look here at the expression palette, you'll see templates for sine, cosine, a few of the elementary functions. In the palette stack, view palettes, you will find that there is a complete palette with all of the elementary functions. Since I already know the syntax for the elementary functions, I don't have that palette in my stack. So here's sine x. Now you can hit the enter key, or you can work it right from the line where you entered it. You want to draw a graph. There's several ways you can proceed. You'll notice that you have a 2D graph right here. If you click this button, you'll get a graph of sine x. If you go to plots, you have these options. You can pick 2D plot, and you'll get the same graph that you got if you clicked on that button at the top of the context panel. Or you can go down here to the plot builder, which is an interactive tool for drawing a graph, and it embeds all of the characteristics of that graph in the worksheet, so that if you ever come back to that spot again, you will know exactly what you did to create that graph. So I'm going to just click 2D plot. You have a graph. It has its own context menu. You right click on that graph, you'll see you can do things to this graph from this menu. You can also do things to this graph from this plotting toolbar. For example, you could put a grid on it. If you right click and you go down to probe info, you could select something like nearest point on the line, and then the cursor becomes a tracer, and you get the coordinates of different points on the graph. If you right click again and go back to probe info, you can copy that data. If you come over here, you can paste it, and now you've pasted in the coordinates of points that you've taken from the graph. So there are other things that you can do here. I think 1-to-1 might be something you might want, so that the x and y axes have the same scaling factors. I believe this is a selector where you can zoom in. I believe this restores. So you can interact with the graph from its context menu or from the toolbar. Now, graphs in Maple have a drag and drop property. So you've drawn this graph. Maybe you don't want the grid on it. Drawing this graph, and you want to say, how does that graph compare to the graph of cosine? So you type cos of x, select it, hold down the control key, drag that expression, drop it onto the graph. The graph plots cos. Well, now that issue of select, hold down the control key, and move. I just moved it to the same line. Is not a Maple thing. It's a Windows thing. It's equivalent to copy paste. Okay, and I make use of that a lot to move stuff around on the screen rather than do a copy paste, which is like you Control C, Control V, and this is just hit the Control key and use the mouse. Now we've shown a bit about how to draw curves. How about graphing surfaces? Suppose we do x squared plus y squared. Well, you could click on this button, you get a 3D graph. You could go down to plots, and you could pick this 3D plot with the variables in the order x, y, which I find pretty convenient. Or we could get down to this tool called the plot builder, which we'll explain a bit later. Let's try this graph with the variables in order x, y. Do you see there's a default domain picked? You can rotate the surface. You can interact with the surface. It has a context menu. So, for example, it has an external light shining on it. You could take that external light off. You could go up here to the toolbar. There are things you can do to the tool with the toolbar. I believe this lets you change how the surface is rendered. This would be just a plain surface. This would be surface with contour lines. You turn it and look at it from above. Now you have a contour plot. So you can interact with a 3D graph. You might also ask, does this 3D graph have the drag and drop property? So let's think in terms of a plane. Z equals x plus y, probably plus something like 15. And let's see if we can drag and drop that onto the existing graph. And 3D graphs also have the drag and drop property. Now, having put in this x squared plus y squared, we might ask, what about an implicit plot? Does Maple do implicit plots? Well, we've already got x squared plus y squared on the screen, so let's make use of that. So I'm going to refer to this x squared plus y squared by its equation label. To do that, you press Control L. L for label. You get this insert label dialog, and you place the equation label number, just the one, no parentheses. Hit the Enter key. That input stands for x squared plus y squared. If I set that equal to 1 and hit the Enter key, the echo is x squared plus y squared equals 1, which is what I wanted to set up. If you right-click on that label and change label to label reference, in other words, that which the label is referencing, then instead of seeing as an input the label number, you see that which the label stands for. So this is now an implicit equation, y of x, x of y. So we can see if Maple graphs implicitly. So you always get this plot builder option here. If you go to where did plots go? Plots. It says, oh, implicit plot 2D. That's very convenient. Variables in order x, y. Well, there's your circle. So yes, Maple will do implicit plotting, and you can do it from the plot builder, or you can do it from one of the options in the context panel. Well, there's one other thing about graphing that you might want to know about, and that's creating an animation in a syntax-free way. Let's try sine of AX. Now you notice, you're a careful observer, that I put a space between the A and the X. Let's just discuss that for a second. AX with no space would be the variable AX. If you put an explicit multiply, here it's an asterisk, so it's Control 8 on my keyboard, you get that dot between the A and the X. Now, I got a math library. I got more than 500 books in that math library. None of them display products with a dot between the factors. They just don't do that in a textbook. And if I'm writing stuff that's supposed to look textbookish, I don't want to see that dot. So the alternative is a space called implied multiplication. If you look at Maple Primes, the Maple Forum, you'll see some of the posters there rail against the space. Some people hate that space. I love that space because it gives me a textbook-looking product. So pays you money and you take your pick. Sine AX. I want A to be an animation parameter. To do that, we'll make use of the plot builder. So I call up the plot builder. It says, animation. Yes, indeed, I want an animation. And I want it to be an animated 2D graph. Now, the animation parameter is picked here, and Maple has decided X is the animation parameter. It's not X, it's A. I'll let X run from, I guess that's minus 2 pi to 2 pi. Build the animation. This is now the animation, and I can run the animation by pulling the slider, and you'll see the value of A changing. I could click this triangle, and it runs. This will make it oscillate, run continuously, and this will make it oscillate back and forth. So A is varying up, and then it's varying down. So you can build an animation in a syntax-free manner. So far, we've learned how to enter math and begin to interact with it. We've drawn some graphs. Now, you may have an expression on your screen, and you want to make a replacement for something in that expression. So it's substitution, evaluation kind of thing. So we need an expression. How about 2x squared? We'll just draw up a polynomial minus 5 x plus 7 is an expression. Now, between the 2 and the x, I did not need to put a space. Between the 5 and the x, I did not need to put a space because Maple looks at that as typesetting rules say, well, the only thing that a 2 and an x together could possibly mean is multiplication, so Maple puts the space in. Okay, I want to put in some number for x. Here's one way to do it. Over here in the context panel, evaluate at a point. And what value would I like to give x? I'll pick 3, see what happens. You put in x equals 3, you get 10. Okay, so that's one way to make that evaluation, x equals 3. Here's another way. In my favorites palette, I have this template which stands for the eval command. And I got that from the expression palette. It's hiding in here somewhere, as I showed you how to right click and you add to favorites. So make use of that evaluation template. What are we evaluating? We are evaluating this polynomial. It has equation label 1. Control L type 1. That is what we are evaluating. We are evaluating, we use the tab key here to move down to the x equals a. What was a? We put 3. If I do control equal, I will see that the value of that expression at x equals 3 is 10. If you don't want to evaluate the equation label, change the label to label reference. And now you see the mathematical statement. That polynomial evaluated at x equals 3 gives you 10. Now, suppose you wanted to evaluate that polynomial at something which was not so easy to type into that little dialog box. So I'm going to choose the floating point equivalent of pi. So how do we get in pi? Well, you can see I have a pi in my favorites palette. I probably got it from common symbols right there. Right click. I showed you how to do that. There's a full Greek palette. You could hunt through here, and there's the pi. It would be equivalent. I get Greek letters from the keyboard. It requires that you press 3 keys simultaneously, down, up, and then the next key you hit will come out in Greek. The 3 magic keys are Control, Shift, G for Greek. Press those down, up, the next letter you hit will be pi, and for us here, it will be the letter P. So Control, Shift, G, followed by P. So there's a pi. Hit the Enter key. So that's the symbol pi. It stands for the ratio between circumference and diameter in a circle. Over here, you have an approximate option. You can go various number of digits, so I'll take it to 10 digits. Now, suppose this is what I wanted to put in for x. Well, not quite so nice to put this into the little dialog box. So that's where this evaluation template would come in. Let us evaluate Control L1. X is, and now this messy thing has an equation label, Control L4, 11.0312. And if you want to see what these equation labels are referencing, use the right click, and you can see what the label number stands for. Now, there is another way to go about this. Depends on the workflow. If the object you want to make the substitution into has a name, you can do something different. So let's give that polynomial a name. So here's the polynomial, Control L1. Let us assign to a name. Q is an easy name to find on the keyboard. So Q now stands for that polynomial. In that mode, that workflow mode, if you have an equation, x equals this thing, so Control L4, you have this equation x equals, and the target has a name. So make use of the substitute into dialog. I'll show you. You are substituting x equals that number into Q, and you get your 11.03, etc. Finally, there's one other way you can do this. Suppose that polynomial or a function. So let me show you how to make a function. F of x equals this polynomial. Now you could use the letter Q here, or we could do Control L1, but don't hit the Enter key. Go over here to Assign Function. And Maple does all the machinery of creating the function whose name is f and whose rule is that polynomial. And if you want verification that we've created a function, type f of t, and you get 2t squared minus 5t plus 7. So we've created a function. And once you've got a function, then f of this number, which has an equation label, Control L4, Control equal, and you again get your 11.03, etc. So far, you have seen me enter stuff, interact with it. You've seen me create a function. You might ask, does Maple understand piecewise functions? So let's tackle a piecewise function. We need to enter a piecewise function. I'll go here to the expression palette. You'll notice there's a template for what looks like a piecewise function or expression. I'm going to take two linear things and paste them together. So how about 2x plus 1? Use the tab key here. For x less than 2, use the tab key. And 10 minus 3x. Tab over for x greater than or equal to 2. So we've got x greater than or equal to 2. Hit the Enter key. So Maple typesets this piecewise function. What does Maple know about this piecewise function? Anything? Or is it just something pretty on the screen? So let's see if we can graph it. Well, you've got this plot builder tool. And it's a 2D plot we would like to draw. And so Maple defaults to minus 10 to 10. And we see that the action is around here somewhere. Is it maybe 0 to 4 might be a more appropriate domain to be looking at this thing. So let's go 0, 0 to 4. And then we notice that Maple has used a connect the dots algorithm. But there should be a gap right here. This little connection shouldn't really be there. So how can we get rid of it? 2D options. Discontinuity. We tell Maple, hey, find and take into account discontinuities. And Maple has now put a little marker on the branch where you do equal to. So we can draw the graph of a piecewise function. What else can we do with it? Suppose we want to ask the question, where does this thing equal 3? Well, graphically, we could do this. You take the 3 and you do a copy-paste. Control-C. We can paste that here. We get a graph of the line y equals 3, where that intersects the branches of this piecewise function. You can see maybe 1 and a little bit more than 2. Well, that's graphical. Could we actually solve this analytically? Does Maple understand piecewise enough to do that? So Control L1 equals 3. Hit the Enter key. I think I'll hit some enter keys here and move that up so it's easier to see. Can we solve this analytically? So there is a solve option. The simplest solve is to say solve. And Maple says, okay, there are two solutions, x equals 1, x equals 7/3, which is just a little bit more than 2. And now you might ask, how did I know to go looking in the expression palette for Piecewise template? And here is where I want to get back to this thing called the Maple portal. Open the help system. That's what this question mark does. Opens the help system. And right here it says the Maple portal. So let's click the Maple portal. So here is the Maple portal. It has a couple of different flavors. The original flavor is something I wrote because my boss was supposed to be writing a something for the blank screen syndrome. That's what this webinar is about. It's the blank screen syndrome. You launch a copy of Maple, you're looking at a blank screen, you want to try things, but you don't know what to do to make Maple implement the stuff that's in your head. So I used to meet him once a week, and I would ask him several weeks running, what did you accomplish? What does it look like? I wanted to see how fancy he was going to get. So finally, he just looked me in the eye and he says, you do it. So I said, okay, what are we trying to do? We've got a blank screen. We've got people looking at a blank screen, and they're saying to themselves, how do I do this? How do I do that? So I wrote down about 150 or more, how do I do this? How do I do that? And I organized them in some logical way and then answered the questions. So that was originally called Portal for Students. Now the engineering portal was kind of spun off, and it's been updated by by Samir, one of our great engineering people, and it's completely different. So if you're an engineer and you want to see what the engineering portal looks like, go there, because I know what this one looks like. So I click this one for students, and you can see here are the logical topics. And if you take this first one, construct an algebraic object. And the very first one is piecewise. And the answers to the questions will either be a worked out example or it will be a task template. Now, what are the task templates? Let's look over here in Tools, Tasks, Browse. And this is the table of contents of the 347 task templates. And this particular task template is probably here in algebra, defining expressions and functions. See, define a piecewise expression, define a piecewise function. This is one of the early ones that was written. So if you click here or here, it would take you to that task template. If you click on the example, this is what you would see. You would see, okay, go to the palette, find the expression palette. In the expression palette, find this template, start filling in the template. It even tells you how to create a piecewise function with 3 rules. You need Control-Shift-R for another row, and you fill that in. Okay, so I recommend that if you've got a how do I question in the back of your head, you remember the Maple portal and see if there is a hint in the Maple portal that tells you how do I do whatever it is that you are trying to do. So I'm going to close this stuff down, and we're back here, and we've seen now task templates. There's 346 more to look at. The student portal got a lot of stuff that you can play with. So here's another mathematical activity you might be wondering about. We've seen differentiation. You might ask yourself, how about implicit differentiation? So we need something that defines a function implicitly. I'm going to type 3x squared minus 5xy minus 5x in space y plus 7y squared equals 11. I can either say x of y or y of x. Well, we'll think in terms of y of x. Can we differentiate, get y prime implicitly? Well, if you go here to the context panel, differentiate implicitly. Dependent variable is y. Independent variable is x. And if you say, okay, you're going to get the expression that you would come up with if you did implicit differentiation. But Maple gives you additional tools to play with. So I'm going to copy this to the clipboard because I'm going to make use of it a couple of times. So Control C, copy that to the clipboard. So I'll put it in here. We could draw a graph. So let's see, anything up here? We can go to the plot builder. We could go down to plots. Let's see, plots. 2D implicit plot, order XY. So what do we see? We see that this is an ellipse, and it's going to have branches. I'm just preserving real estate. So branches. Well, you can actually solve this thing for y of x explicitly. So let's do that. So let's solve this explicitly. So we go to solve. Solve for y. 2 solutions. Now, if we had if we had chosen in solve obtain solutions for y, we would not get that bracketing structure. So sometimes you want the bracketing structure and sometimes you don't. So this is an equation in a list, and this is a list of lists. This is just a sequence of 2 solutions. And this is more convenient for doing the next step because I want to draw a graph. And here you see one branch in red and one branch in blue. So this is what we mean when we say y of x has been defined implicitly. We have this red branch, we have this blue branch. But this is the additional kind of thing that you can explore if you've got a tool like Maple. Now, there is a task template that will allow us to take the implicit derivative stepwise. So let's go to Tools, Tasks, Browse. We've seen this table of contents before. Tasks, Differential Calculus, Derivatives, Implicit Differentiation, and the simplest case is the one that we're looking at. Here is a task template, which we can embed either by clicking this button or that button. This means you get the extra verbiage. This means you get enough to make the thing work. So let's do a clear all and put in, Control V, what we want to differentiate implicitly. The dependent variable is y, the independent variable is x, and this button gives us the implicit derivative. But now here are the steps that you would go through. First thing is you got to locate the invisible x's. So you want to make every y become a y of x. Then you differentiate with respect to x. This is what you get. If if a student is doing this, they may not be as familiar or as comfortable with differentiating a product like xy of x or y of x squared. So we click this Stepwise button, and that launches the differentiation methods tutor. Now we haven't talked about tutors yet, so I'm going to show tools, tutors. These are the subject areas that have tutors. Tutors are pop-up tools that let you do point-and-click syntax-free computing. So calculus of a single variable. Look over here. You have differentiation methods. You have integration methods. And you have limit methods. So these are three tools for implementing computations stepwise. So I'm going to bring that up from here again. Click the Stepwise button. Pull this thing down, make some more room here. So the way you work this is you select a rule to apply. If you select a rule that doesn't make sense, like you say quotient rule, Maple says, no, don't do that. Look over here. There's a plus in the expression, trying to push you to pick the sum rule. If you shrug your shoulders and say, I don't understand anything, tell me what to do next, Maple will say, all right, look, the sum rule has been applied, and this is what you get. Break everything up into pluses and minuses. So let's look at some of these terms. There here you have a derivative of a constant. So if you take the derivative of a constant, you get 0, that's gone. You look at this first term, there's a 3x squared, constant multiple. You got to take the constant multiple out. Now, if you think something like the constant multiple rule is one that you do not want to keep fussing over, you can tell Maple, these are the rules I understand, don't bother me with them. So you can make those choices. So derivative of x squared yields to the power rule, there's your 6x. Well, you got constant multiples here and here. I'm going to hit the constant multiple button twice. Now you have a derivative of a product, so you click product rule. Maple says, okay, you differentiate the first factor, multiplied by the second. This is vice versa. This is the first factor times the derivative of the second one. So here, derivative of x with respect to x is the identity rule, and you are now left with this chain rule. So you click chain rule. What does Maple do? Well, it's the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, what's the outer function? The outer function is squaring. There's no notation for the outer function being square. So Maple writes an object underscore x naught, an object squared, and you are differentiating with respect to that object. This is power rule. And so we have now obtained the derivative, which is what you see here. Isolate the derivative. Okay. This is what Maple got from its context panel. Well, on a pencil and paper, you'd take away the y of x finally, and you'd have that. Now, to show the power of the syntax-free computing tools in Maple, I've pasted in this equation, and you'll notice it's in a gray box, which means it's non-executable math, and I would like it to be executable math. So one way to do that is to right-click, and you see executable math. And now it's in the blue box, so now it's executable. So if I hit the Enter key, it will echo back. And what I'm going to do is I'm going to make the replacement y becomes y of x from the context panel. So y becomes y of x. Now I have to differentiate with respect to x, so I can differentiate with respect to x. And now I need to isolate y prime. So here is y prime. So let's go to solve and isolate expression for that derivative. And I've got the implicit derivative done stepwise from just the syntax-free tool. Okay, let's try one more thing. How about an initial value problem, differential equation, second order constant coefficient, so a damped driven oscillator. What would that involve? So y double prime. Now we can use this double prime symbol, but that's differentiation with respect to x. This is a dynamics problem. So the independent variable is really t. And there's two ways we can handle this. We can change the meaning of prime. I can show you how to use over dot to represent differentiation with respect to t, or I can just put an explicit t here and go on. So there's y double prime plus 4y prime. I'm going to use this prime here, but it has to be of t plus 13y, and this has to be of t equals, how about we drive it with a cosine 2t. Okay, so there's a differential equation. Now, if I have not made any mistakes here, I didn't put a t in here. So I put the t in here. Now Maple is happy with the differential equation. And it gives me two choices in the context panel. Solve the DE. That means I'll get the general solution with two arbitrary constants, or solve it interactively. Okay, so this tool is called and has been called the ODE Analyzer Assistant. I'm going to close that for a second. I'm going to go here to Tools, Assistants. So here are some pop-up tools. It used to be included in this list. It has been moved from assistants down to tutors. And if you go to differential equations, you see ODE Analyzer. So it's now been moved down to a tutor, but it's still called Analyzer Assistant. Okay, so let's bring it up from here. Okay, I want to give some initial conditions. So I do that through this button here. Y at 0. How about I give it the value 2? Add that in. This is a drop down. Y prime at 0. How about I give it the value -1? Add that in. Click done. So now I have an initial value problem. I can solve it numerically, but I can certainly solve it symbolically. And if I click solve, I will see the solution. And if I want to see it in a bigger window, I can see it in a bigger window. And if I want to draw a graph of the solution, I click plot. If I want to see graph of y prime as well as y, I could make a copy of y and then change y to y prime. And now when I click plot, I will get a graph of y and y prime. This checkbox here will show me the commands. There's the desolve command for getting the solution. There's the plot command for drawing the graphs. If you are trying to get across the notion of the effect of damping or mass or spring constant, rather than get tied up with the syntax of the desolve and the plot commands, here you have a tool that will give you the solution, draw the graphs, discuss properties before you worry about syntax. And then you can return a solution or a graph, or you can even return the Maple commands if you want to play with those, or you can just return nothing. Okay, so here, tool for solving differential equations and initial value problems. We could even have given some simple boundary conditions. But I said I would show you something about differentiation with respect to t. Now, here is a template, and I'm pretty sure I got that from Accents. Yeah, Accents. Here, double dot. You could use that template, or you can do it from the keyboard. So you want to jump up on top of Y. And you can jump up on top of anything by pressing the following three keys: Control, Shift, and the quote key. Now you've jumped up on top of Y, you put two periods. That stands for differentiation with respect to T.